Good day, physics champion. In today's video, we will speak about the equations of motion done by Newton. Actually, they are four equations, and we need to understand the proving of them. Like, how can we deal with any problem in physics using the equations of motion? Please stay in. In the first equation, we could say that the acceleration equal mainly the change in velocity divided by time. And actually, that also could be considered the definition of the acceleration. When it comes to the change in velocity, it means the final velocity minus the initial one divided by the time. If we do cross multiplication, we will finally get v equal to u plus at. And that was the first equations of motion. As you see in the first equation, we could say the final velocity, equal to the initial velocity plus the acceleration of the body times the time needed from the beginning of the journey to the end. But in the second equation, as you see here in the first one, we do not have anything related to the displacement. So if we want to involve the displacement, we could write that the displacement equal to the velocity times the time. In the previous equation, we mentioned two velocities. One of these velocities was the final and the other one was the initial. But the velocity here, it could be considered the average. And as you know, mathematically, to find the displacement, we could say that the average velocity times time, so any average between two numbers is going to be the first number plus the second number divided by 2. Going to give you the average. Then we still have times time. And this equation, we could consider it the second equation of motion. So in the second equation, we involve the displacement. So we could write that the displacement equal to the average velocity from the beginning to the end of the journey times the time. When it comes to the third equation, we're gonna do something different. Like this v here, the final velocity in the second equation, we could substitute it depending on its value in the first one. So if we do so, mathematically, we will get this step, like s equal the same bracket, the same fraction, but we still have here 2, and this is plus u, and instead of v, I'll write the value of v in the first equation, which is u plus at. Remember, in this part, consider v when it comes to the first equation. And by the end of the story, we still have time. If you analyze this part, or make it more simple, we will get that s equal u plus u divided by 2 times t, gonna give you ut, plus at divided by 2 times t, will give you a t square. We still have divided by 2, which we can write it as half. That was the third equation of motion. In the third equation, we have something different, which we have the displacement and the acceleration in the same equations. By the end of the story, it depends on the given in any problem. When it comes to the fourth equation, we will again take the benefit of equation number 1, like if I just copy that equation, so fourth equation. We know from equation 1 that the final velocity equal to the initial velocity plus at. So when it comes to this part, mathematically, I have no doubt I can say that v square equal to u plus at all square. And when it comes to calculus, we could say that it means that v square equal u square plus 2uat plus a square t square. One before the last step, I could write velocity square equal to u square plus. In this step, we need to make it more simple for us to take a common factor between what we still have here, these two variables. And I'm gonna choose 2a as a common factor. Then you will know why we especially use 2a as a common factor here. So I will get what's still inside the bracket ut plus, I got already 2 outside, but there is no 2 in front of a square t square, so I'm gonna write that as half times 2 gives you 1. Then I got a outside the bracket, so we still have a here. Then there is no t outside the bracket, I'm gonna write t as it is, t square. As you see this part, it gives you the same value for the displacement in equation number 3. So I'm gonna substitute this bracket by s, I mean the displacement. So depending on that, mathematically, I have no doubts, I could write v square equal to u square plus 2a, and instead of the entire bracket, we could write s. That was equation number 4. So as you see, all these equations, they finally came from the same equation when it starts with the definition of acceleration. So I could write here the acceleration equal to change in velocity divided by time. That was the main part that we got. And we could obtain the 4 equations out of these equations. To choose any of these equations could be used, it depends on the given. And it depends on the required calculations that you need to do. In the last equation, I mean the 4th one, we have a relation between the velocity square and the displacement and the acceleration. And as you see, there were all of them, the equations of motion, actually give you the same results, but it depends on the given. That was the end of the equations of motion. Please observe them and write the proving of each one of them to get familiar with that. See you with past papers about that next lesson. Bye.